Hello everyone. Now in this video we will discuss some more operations on matrices, like how do we find transpose of a matrix. So what do we mean by transpose? Transpose is nothing but interchanging the number rows and columns of the matrix. So interchange row and column. So when we interchange row and column of a matrix, it becomes a transpose of a matrix. Okay, how do we denote it? There are many notations. So we can sometimes denote A prime or sometimes A T. T for transpose. Okay, so these are most commonly used representation for the transpose. So generally, again, when we find transpose of a matrix, it will be a matrix again. So if A is a matrix of order m by n, then A transpose will be a matrix of order n by m, because the rows and columns get changed. When A is a matrix of order m by m, there will be m rows and columns. Okay, in the transpose it becomes reverse. It becomes n rows and m columns. Okay, let us understand this with the help of an example. Say if A is a matrix of order say 2 by 4. So 2 rows, 2, 3, 4, 5, 0, minus 1, 3, 2. 2 by 4. So as per the definition, the transpose should be a 4 by 2 matrix. So it will be having 4 rows and 2 columns. So you will be having numbers over here, 4 rows and 2 columns. So it's actually very simple. You read it horizontally from left to right and write it vertically from top to bottom. So the numbers are 2, 3, 4, 5. Write it here, 2, 3, 4, 5. So basically what happened? The row becomes the column. Same is for the second one, 2 minus 1, 3 and 2. Easy? Okay. Let's take another example. If we have a matrix, say, let me use another name. I'm always using A. If we have a matrix B of order 2 by 2, then the transpose of B will be again a matrix of order 2 by 2. What will happen? Row become column, column become row. 9, 6, 7, 12. It will become 2 by 2. Finish. Now let's move to next concept, determinant of a matrix. Now this determinant is different than the previous operations. See, determinant of a matrix, it's a unique number by which we can represent a matrix. So it will be a number. So it will not be a matrix. This is the difference. So far when we studied about transpose, multiplication, addition, subtraction, it comes out to be a matrix, but determinant of a matrix is a number. So let's consider the determinant. Again, we cannot find determinant of any matrix. So the condition is that matrix should be a square matrix. If the matrix is not a square matrix, we cannot find the determinant. So we can sometimes also say determinant of a square matrix. Okay, otherwise it's not possible. So this is important thing. So you cannot find, say if I give you this matrix A, find its determinant, you can simply write it as it's not possible because it is not a square matrix. So let's start with a 2 by 2 matrix. Okay. So let us see how do we find determinant of a square matrix for a generalized matrix. Let A be a 2 by 2 matrix with the elements A, B, C and D. Okay, then its determinant is given by, first of all, how do we denote the determinant? We can either write DETA, this is the notation, okay, or we may write modulus of A. This both means the determinant of A. Okay, this is the representation of the determinant. How do we find it? Determinant of A is cross multiply the elements diagonally and subtract them. A multiply D minus B multiply C. So for example, if A is a 2 by 2 matrix with the elements 2, 3, minus 1, 5, then determinant of A will be 2 multiply 5 minus 1 multiply 3. So this gives you 10, minus minus become plus 3, 13, determinant of A. Okay, simple. Now moving on to 3 by 3 matrix. So when the matrix become 3 by 3, the formula change. So what is it? Let A be a matrix, 3 by 3 matrix. So let me consider a generalized matrix with the elements as follows. Okay. Then in this case, determinant of A is obtained by, now actually there are two ways of doing it. Let's consider first the standard way, then I'll tell you the shortcut as well. So we start with the first row. We can find the determinant, or we can say we can expand the determinant by any row or any column. More preferably, we prefer to do it by first row. So we consider first position of this as plus, minus and plus. Okay, what's the reason that this sign is plus? Because if you know the position is A11. So if you add 1 plus 1, you will get 2. So minus 1 power 2 means 2 is an even number, so it is a positive sign. Whereas if you check this position, this is A12. 1 plus 2 gives you 3. So it's an odd number, gives you the sign negative. Okay, so let's see how to do it. It is A times, now as we are expanding by A, so we will see the rows and columns where A is intersecting. So whatever is left, we multiply A with the determinant of the remaining quantity, D, J, F, K. Then the next sign is minus B. Now B is B is intersecting with first row and the second column. So what are the elements left here? Elements left here is E, I, F, K. So this will be the determinant of this, plus C times determinant of, with C, C will be the last column and the first row. So it will be EI DJ. See, important thing is this is determinant. So what this will give you? This will give you A times. Now this is it is a determinant of 2 by 2 matrix, right? This is 2 by 2 determinant. So it will be obtained as we obtain the determinant above. How we did it? We cross multiply and subtract. So same thing here. This will be cross multiplication D with K minus J with F minus P times determinant EK minus FI, and then C times EJ minus DI. So this will be determinant of a 3 by 3 matrix. So you can further simplify it. That will give you the determinant of the matrix, which will be a unique number. Now, as I said before, there is another way of finding the determinant for 3 by 3 matrix. You may find it much easier. Okay, so let's consider the same matrix. Okay, in this what you have to do, you write the first and second column again. So we write first column A, E, I after this, and then B, D, G. Okay, then what we have to do, we have to draw the diagonals. 3 by 3 matrix, so we will be drawing 3 diagonals. This is one diagonal, second diagonal B, F, I, third diagonal is E, C, E, G. So what does it means? We have to multiply these 3 elements. Okay, so this will give you A, D, K. This multiplication gives you B, F, I. And this gives you the multiplication C, E, G. So we multiplied diagonally the elements from top to bottom. Now we have to perform one more multiplication, diagonally going in the upward direction. Okay, remember, when we are going in the downward direction, we have to start with the first element, firstmost element, first row, first column. For down upward, we start with the third row, first column. So this gives you the multiplication I, D, C. This gives you multiplication J, F, A. And this third one gives you the multiplication K, E, P. Now, after doing this, it's looking complicated because it is in terms of variables. Okay, when you do it with the numbers, you will find it much easier. So now, once this is done, how do we write the determinant? Start with the arrows which are going down. So we got 3 terms, A, D, K plus B, F, I plus C, E, G. We add all of them. Okay, and those which are going in the upward direction, we subtract all of them. So minus I, D, C minus J, F, A minus K, E, B. When you simplify, you will get your answer. So if you check, this will give you the same result as we obtained by the previous method. So let's see. This is, if you multiply A with dk, you will get the term ADK, which is over here. Okay, then the second term is AJF with the negative sign. You have AJF with the negative sign. So it's A. Similarly, you have the term BEK. This is KEB. Okay, and so on. So if you check, the answer is same. So you can pick any method, whichever is easier for you. So let us solve an example based on it. Find the determinant of matrix D, which is say 2, 3, 4, 7, 0, 5, 1, minus 1, 2. So let us solve it by the second method. Okay, so what I have to do after this matrix, let me write matrix D. 2, 3, 4, 7, 0, 5, 1, minus 1, 2. This is the matrix. I will write the first 2 columns here. 2, 3, 4, 7, 0, 5. Then we multiply diagonally starting from top to bottom. 2, 0, 2. This gives you the number 0. 7 minus 1, 4. 7 times 4, 28. With the minus 1 gives you minus 28. 1, 3, 5. 5 times 3, 15. Moving upward. Upward diagonal. 4, 0, 1 gives you 0. 5, 1, 2 gives you 10. 2, 3, 7. 2 3s are 6. 6 times 7, 42. So determinant of D will be the elements which are in downward direction will be added. 0 plus minus 18 plus 15 minus those which are going upward will be subtracted. Minus 0, minus 10, minus 42. So when you simplify, minus 18 plus 15 minus 10 minus 42. So you will get a negative number. Yes, it is possible to get the determinant as a negative number. So we will get minus 55. So this is how we find the determinant of a matrix, 3 by 3 matrix.